Okay, chapter 2.5, systems of linear, I forgot the R, equations. Okay, systems of linear equations, and it's kind of an interesting concept. It's a system, so it's multiple things drawn together, and they're lines. Okay, basically it's just a system of lines, and you can have an equation for a line, and it becomes a system because of how they interact. It has to be an interaction. So you have a line, and you have another line, and there's usually a point where they cross. And usually, okay, you could have two parallel lines. This is the other option, and they never cross. You could have one line that has some equation, and you could have another line that's laid down right on top of it. Okay, and these have no points in common. There's no points that they share. This two lines have all points in common. Okay, but the most common is just two random lines that eventually cross each other, and they have one point in common. And that's kind of what we're going to work on. I'm going to go ahead and write it in common. All right, one point in common, and this is the important thing that we need to pay attention to. All right, so for instance, if there's a point on this line and it happens to be like 3, 5, and there's a point on this other line that also happens to be 3, 5, if they both have the same point, then that is a point where they cross. Okay, now if every point is the same, then it's all points, and if no points are the same, then it's no points, obviously. This kind of sounds simple, but believe me, it gets a little strange. So the first example is just using a table. And again, there's two equations. There's one that's called y equals x minus 5, and you see this is not in standard form. This is in point slope form, or slope intercept form. That's the one where you have a slope and you have a y-intercept. And then another line is y equals negative 3x plus 7. Okay, so we got a table form. Now the book uses a table form that goes kind of left to right. Use my straight lines here, and you put your equation in, and I'm going to show you both because it's important. So we'll see what I can do with this. And you can look at it in your book if you want to. It's page 78. All right, so our first equation goes in here. Oh, no, it doesn't. This is just the x. The second equation, the first equation goes in here. There we go. And the second equation goes in here. Let me just back that all up so it looks cleaner. All right. And we'll just go ahead and write it in. Y equals x minus 5, and y equals negative 3x plus 7. Okay, so for any x value we put in, say they choose 0, 1, 2, and 3, there should be some y. This is sort of a function notation. We're getting into functions. None of these colors look good together. If you put 0 in for the x on this equation, you get 0 minus 5. So then y is just equal to negative 5. So for this one, you'd put a negative 5 in right here. Okay. If I were to put 0 in this equation, that's y is equal to negative 3 times 0 plus 7. And 3 times 0 is 0. Negative 3 times 0 is also 0, so y is equal to 7. So you get a 7 in here. So you kind of progress through by putting each of these in to here. We've got to just keep going with that until we get all of our points. And what happens is your point looks like this. For equation number 1, you have a 0 and you have a negative 5 for the y. So see, this is your x. They've got it labeled here, but your y is your answer, your function. After you put in the x, what comes out? What is the answer? You get a negative 5. And over here, the second equation is 7. So it might be that we ought to separate these just a little bit. And no, I don't know if I can make it work. I can kind of make it work. I'm just going to move this over here like that, and then I'm going to move this because it belongs over here like that. Okay, so the answer to this one is 0 and 7, and the answer to this one is 0 and -5. And you gotta just keep doing that, and then after you get all your points, you gotta plug them in. Or you just have to see that they have the same point. These 2 points don't match. 0, -5 and 0, 7 don't match. If I move forward and I put in a 1, then I have y equals 1 minus 5. That's this first equation. And 1 minus 5 is -4. So for this one, 1 and -4. This is the point that I would graph on a graph. So it's 1 and -4. And over here, if I put in 1, y is equal to -3 times 1 plus 7. So y is equal to -3 plus 7. So y is equal to 4. So I've got a -4 and a 4. Okay, and so this point is going to be 1, 4. So I've got this one and this one, and they sort of just go together. I'm going to just keep deleting these because we need the information, but I'm not making it easy. There we go. All right, so now if we put 2 in, y is equal to 2 minus 5. I put 2 in for the x right here, 2 in, and so y is equal to -3. So that's -3. Okay, and over here, putting a 2 in again, y is equal to -3 times 2 plus 7. And that means y is equal to -6. -3 times 2 is 6. -6 plus 7. So y is equal to +1. All right, good. So now if I go ahead and put these down, I've got 2, 1 for this one. And I have 2, -3 for this one. I hope that's making sense. This is actually not the way I like to do it, and I'm going to show you real quick the way I like to do it when we get one more done. So we got 3 here now. So y, keep forgetting to do that, y is equal to 3 goes in for x minus 5. So y is equal to -2. So that equals 3 and -2. And over here we have 3 and -2. We put 3 into the x and out came -2. Do the same thing over here. Y equals -3 times 3 plus 7. Okay, and so y is equal to -9 plus 7. And then y is equal to -2. Oh, I see. I did something a little silly. You're gonna have to just bear with me here as I try to erase. I can't do it. Maybe it's this one. Got to erase this 3, and I've got to erase the -2. Okay, there we go. Back to this. Oh, and I got to make sure I grab the right tool. Slow computer. I'm too fast for it. Okay, I need this one, not the eraser. Okay, got it. All right, I think. Yep, that works. Why did that color tablet come in? All right, so here I put in 3 and I got -2. And here I put in 3 and I got -2. And this is sort of the magic moment that I try to destroy. We got the same answer, the same y for the same x. So I have a 3, -2 for this one. And I have a 3, -2 for this one. And that's important. Go ahead and get rid of this. That is ding, 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 the final answer. That's what we've been looking for. This -3. This is the point where the 2 lines cross. Now we still don't know what those lines are, but we know that somewhere along the line, at 3, -2, they cross. And I could draw them. We've got the points to do it. What I want you to see is, real quick, the way I prefer it. And I don't know why the book does it this way. They probably have a really good reason, and so I didn't want to ignore the reason. But we've got the first equation is y equals x minus 5. And I like to use what's called a T-chart. Put an x on the left and a y on the right. Okay, so if x equals 0, and 0 take away 5 is negative 4. If x equals 1, put the 1 under the x. The 1 minus 5. Oh my, Mr. Armstrong. Let's go back to 0. 0 minus 5 is negative 5. I'm thinking ahead of myself. 1 minus 5 is negative 4. 2 minus 5 is negative 3. And 3 minus 5 is negative 2. You can kind of see the pattern. As we're going up, we're going down. I like this pattern. This turns into 0, negative 5. And this turns into 1, negative 4. And so for our other equation, we can do the same thing. Y is equal to negative 3x plus 7. And we make a T-chart. Looks like a T. We've got our x on one side and our y on the other. Put in 0. Negative 3 times 0 plus 7 is 7. Negative 3 times 1. Now this one is a little more complicated, so you might have to go times 1 plus 7 is negative 3 plus 7. So for 1 you get 4, because negative 3 plus 7 is 4. Right? It does make sense to go ahead and write it out to make sure you're doing it right. For the number 2, you have negative 3 times 2 plus 7, which is negative 6 plus 7. So that's 1, because negative 6 plus 7 is 1. Oops. Have to just keep on moving. And then 3, negative 3 times 3 plus 7. This is our equation up here. And you get negative 9 plus 7, which is negative 2. So we get negative 2. And this is where you can see it. This one matches this one, and you know you can quit. If you're to draw these, if I draw, say, in green, lime green here, I've got 0, negative 5, which is down here. And I've got 1, negative 4, and I've got 2, negative 3, and I've got 3, negative 2, and I've got this line that kind of goes through here. And then if I draw this one, say in a purple or something, I've got 0, 7, it won't let me draw. Oh, because I'm on that one. Okay, 0, 7, and I've got 1, 4, and I've got 2, 1, and I've got 1, negative 2. And then I draw this one, and there's one point in common right here. And that point is 3, negative 2. So the system of equations has the two lines crossing at that one point. That's the key idea. You have to solve both equations and graph them. Okay, so the first way is just to see it on paper. The second way is to graph it and see that they actually cross. In using a graph, you could just use you could use this T-chart like we just did, or you could simply use your slope intercept form, where you know this is at negative 5 and the slope here is 1, 1. So you go up 1 over 1, up 1 over 1, up 1 over 1, and then you draw your line. This one, the y-intercept is at 7, and your slope is at negative 3, which is negative 3, 1, which means you go down 3 over 1, down 3 over 1, down 3 over 1, and you get your same line just using slope-intercept form, y equals mx plus b, to draw your graph. You can skip the T-chart altogether at that point. Okay. The video is getting too long, so we're going to let you move ahead.